number 2 of Bobcat gear. Got on my red Bobcat shirt for today. So I hope you've got on your Bobcat gear as well. All right, so today we're taking area a little bit farther. And we're starting to think about finding the area of combined rectangles. And what that means is that you've got a figure that has more than one rectangle in it. And we're going to figure out how we can use what we know about area to find that total area for that figure. So let's look at this example, right? We've got a garden here that's split into 2 sections. We've got a rose garden and we've got an herb garden. And so what we're going to do is we're going to figure out, well, what's the total area of these 2 combined gardens or these 2 combined rectangles? So the first thing that we're going to do is we're going to notice that in this diagram, right, it's already kind of split, right? Here's our herb garden in this section down below, and here's our rose garden up top. For our work today, I'm going to use blue for our herb garden, and then I'll use red for our rose garden, since roses are often red, to kind of keep our work organized so that you can follow along with me as we're working. So let's start by just thinking about the herb garden on its own. Let's figure out the dimensions of that herb garden so that we can use our area formula. We know that area is base times height, right? Area equals base times height. Well, let's look at this herb garden. What could we, if we want to define the dimensions of that garden on its own, we could look and we can see, all right, our base right here is 4 meters. And then over here it tells us we also have 4 meters on this side. Now you might be thinking, wait, Ms. Sharma, it actually says 7 meters over here. But think about that. Does that make sense? If we look at how this is split, when we split these gardens in half, or not in half, but on that line right there, our 2 sides of our herb garden look to be equivalent. When we split the garden, that 7 meters also gets split, right? And so we know that everything above the split is 3 meters because of this dimension here, and everything below the split is 4 meters. So right here on this figure, everything above is 3 meters, everything below is 4, right? So I know that my measure of my side is actually 4 meters, and that makes sense because this figure is a square, right? So we know that all 4 sides are going to be the same. So if we want to find the area of this square, we can do base times height, which would be, in this case, area equals 4 times 4, right? And remember, I'm thinking in meters this time, right? So 4 meters times 4 meters. So 4 times 4 is 16 meters squared, right? Because we're thinking how many of those square units does it take to cover up this entire area of this herb garden? Now we can take the same strategy and apply it to the rose garden, right? So I'm going to switch over to red, right? And we're thinking, okay, well, what are my dimensions of this rose garden? And I can see clearly that that top dimension is 8 meters. And then we already talked about the 3 meters over here on the side. So this rose garden section is 8 meters by 3 meters, right? So if I do my area formula again, area equals base times height, I could say that area equals, right, 8 times 3. And then when I do 8 times 3, I get 24. Again, we're thinking meters squared, so I have 24 meters squared. Now, we're not done because we want to know the total area of this garden, right? And right now I have my rose garden area on its own, and I've got my herb garden, but I want to know what that area is all together, right? So I'm going to add up those areas. So 24 meters squared plus 16 meters squared equals what? What's that total amount? If you need to, go over to the side and write it vertically for yourself. Please do that. So I've got 24 plus 16. 6 and 4 makes a 10, and I regroup. And 2 plus 1 plus 2 is 4. So I have 40. And then, of course, don't forget our units, which is meters squared. So our total area for this rose garden is 40 meters squared. All right, we're going to try one more all together before I have you go off on your own. So let's take a look at this figure. This figure, I'm going to show you 2 ways that you could tackle this problem. And and you can also pause me along the way if you want to give it a try on your own. So let's say that this is the area of a room that I have that I'd like to put some new carpet into. I need to make sure that I have the correct dimensions so that I can tell the carpet people how much carpet to buy. So let's start by thinking about how we can split this figure up, right? I could split the figure on this small section right here because I have all of those dimensions easily laid out for me. I could also split it along this measurement, along this part here. And then I would just want to double check that I have all of my measurements. I have 8 and 16 for this rectangle. This one would be 9 by 24. So you could tackle that problem in 2 different ways, just by figuring out how we could split this figure into 2 rectangles that we could find the area of. I'm going to stick with this one. All right, so now I've got 2 figures. We'll call this figure A and this one figure B. Okay, so let's start by finding the area of figure A, right? So if I use my formula for A and I find that area equals base times height, I can use that formula to help me, right? So area, in this case, I see that I have a base of 8 and then a height, so right, a perpendicular line segment to the top, to the next section, or next part of my figure of 9. So I can do base times height, or 8 times 9, and then that area would be 72 feet squared. Remember, feet squared because my units are already included for me, and I'm thinking about how many little squares can I fit into this section, right? All right, let's think about figure B now. For figure B, I need to be careful and look at my dimensions carefully, right? I don't want to accidentally put 24 because 24 is the length from one end all the way to the other end, but I only need to stop at this dotted line, right? Because I've already accounted for the length that's in this part, this section A. So I'm going to be only looking from the dotted line to the end of my figure, which I see up top is 16 feet, right? So if I'm thinking area equals base times height, I know my area will be equivalent to the product of 16 and my height, which is 17, right? There's my perpendicular line segment that spans from the bottom to the top of my figure. If you're not sure what 16 times 17 is off the top of your head, that's okay. Go off to the side and write out that math, right? So 6 times 7 is 42. I'll regroup. 7 times 1 is 7 plus 4 is 11. Add my 0 for that place value, and then I'm going to move on. I'm going to cross off that 4 that I regrouped so I don't get confused and accidentally add that again. 1 times 6 is 6. 1 times 1 is 1. And then I can go ahead and add 0 plus 2 is 2, 6 plus 1 is 7, and 1 plus 1 is 2. So I get 272. My units are still feet squared. So now I can take these 2 areas and I can add them together because again, I'm trying to find that total combined area. If I do that, I get 272 plus 72. 2 plus 2 is 4. 7 plus 7 is 14. And 2 plus 1 is 3. So I get 344 feet squared. All right. So one way to find the area is to, like we did in that first problem, break that figure into 2 smaller figures that are both rectangles or squares and find their independent areas and then add them together. Another thing that we could do is we could use subtraction. This method's pretty cool. I want to show you how that can work, right? So we can find the area of this whole entire rectangle. You might be saying, but there's not a whole rectangle there, right? That outline that you just drew, those line segments don't exist. Well, you're right. We're going to use subtraction in a minute, and we'll account for that, right? So if I found the area of this whole large rectangle, I know that would be 24 feet by 17 feet, right? Here's my base, 24. My height, that perpendicular distance from the base to the top of my figure is 17 feet. right? So if I do area equals base times height, I would have area equals the base of 24 times my height of 17. If I go off to the side and do 24 times 17, 7 times 4 is 28. 7 times 2 is 14, plus 2 is 16. Add my 0 to account for that place value. Cross off that 2 so I don't accidentally account for it again. 1 times 4 is 4. 1 times 2 is 2. And then I can add. And I end up with 408. So I could say the area of this entire rectangle is 408 feet squared. Now, we're not done. This is where our subtraction comes into play, right? We know that the measures of both of these sides here are 8 feet, which means that this is a square that I added to this section of our rectangle to complete the rectangle. So what I can do is I can find the area of this square here, right? And if I do that, I know that that would be area equals base times height. My base and my height are the same. They're both 8. 8 times 8 is 64 feet squared. So I know that this section right here, this is 64 feet squared. I know that my entire rectangle here was 408. So I need to subtract those 64 square feet from my 408 square feet. So if I do that, I have 408 minus 64. 8 minus 4 is 4. Can't subtract 6 from 0, so I'll regroup. 10 minus 6 is 4. And I bring down my 3, that's 344 feet squared. And as you'll see, that's the exact same answer I got when I split my rectangles into 2 sections. So what you're finding here is that if you're trying to find the area of a combined rectangles, you can use addition by breaking apart those 2 rectangles and then adding their total areas together. You can also find the area of combined rectangles by finding the area of the total figure that by adding to that figure to make it a complete rectangle, and then subtracting whatever the area is of the section that you added. Both of these are strategies that can work for you as you're finding areas of combined rectangles. Thanks, guys.